Hello, algebra students. Today we're looking at rational exponents day 2, and we're going to be doing operations using rational exponents. Remember, rational exponents are fractions. The exponents are going to be fractions. And remember also, we will be putting them in radical form as the last step, so you'll continue to get practice using square roots and other radicals. But first, let's review just looking at the rules for operations using exponents when we have whole number exponents. So these examples are all whole numbers. We see when we multiply, you add the exponents, right? Add the exponents when the base is the same. So we have the base is x here. We add the exponents. 3 plus 4 is 7. Okay, for raising a power to a power, we have x to the second power raised to the fourth power. You multiply exponents. In this case, 2 times 4 is 8. And then we have division. With the same base, you have x to the sixth divided by x to the second. Subtract 6 minus 2 is 4. And then last but not least, we have a negative exponent. And in the case of negative exponents, you flip the base and the exponent to the denominator, and it becomes positive. In this case, it was negative 2. We put it in the exponent, it becomes positive 2. Okay, so look at this note down here. We will use the same properties with rational exponents. So you add them when you multiply. You subtract the exponents when you divide, and so on. When they're fractions, you do it the same. You do the same thing. And then after all of that exponent arithmetic is done, we'll put it in radical form if necessary to finish simplifying. Okay, so look at these examples. These do have fractions in the exponent. So we have a power raised to a power, right? We have a power of 2 raised to the power of 3 halves, but one of those this time is a fraction. But we still follow the rule, multiply exponents. So that exponent arithmetic I'm going to do in a different color down below. And it's multiplying 2 times 3 halves, but we'll write 2 as 2 over 1. Multiply that by 3 halves, numerator times numerator, denominator times denominator, and we get 3. That's the result of our exponent arithmetic. So that just applies up here. Multiplying the exponents, we got 3, right? So that becomes our exponent. We simplify. 3 to the third power is 27. And that's it. Okay, look at the next one. We have division this time. So we subtract exponents. The base is the same. So we'll do our exponent arithmetic down here. 3/4 minus 1/2. Okay, so we'll get the common denominator first. To subtract, you need a common denominator. So we rewrite 1/2 as 2 over 4, 2/4. Subtract, you get 1/4. So that's our exponent that we apply to the base. So the base is 16. The exponent we just found was the 1/4. And now we will put that in radical form in order to finish. So we have the base is 16. What's the exponent is the numerator of that, right? And the index of our root is the denominator, which is 4. So that goes there. So we have the fourth root of 16 to the first power. Now that's pretty trivial to just go ahead and take 16 to the first power is 16 and take the fourth root of that. But just to remind us of the order, I'm going to draw this circle and say we want to generally do the root first. And that looks funny because when you look at this expression that we have, that literally says take 16 to the first power, that's inside, right? And then take the fourth root of that. And that really is what that says. But you get the same thing either way, and that can be proved that you always do. So it makes more sense to do the root first, since you get the same thing anyway. So that's what we do. This time the exponent is small, it's just 1, and the order really doesn't matter. You get the same thing anyway, either way, so do whichever you want. But sometimes the exponent is large. And since we get the same thing either way, we don't want to take a number to a large exponent first, because we would get a really, really big number that we'd have to deal with. So we do them in this order. We just take the root first. Get the same answer either way. So let's I'll erase this over here, and let's do that. So we take that fourth root of 16, and that is 2. We'll cake that to see it. We'll just cake it in the other color. Do it right over here. 16 divide by 2. You get 8. Divide that by 2, get 4. 2, 2, and so we have a single group of 4. We're looking for groups of 4 because our index is 4. Single group of 4, so we bring it out, it's a 2, and there's nothing inside. But now, after we do that fourth root, now we raise that to the exponent, right? The exponent is 1, so that's pretty trivial. But just for practice, to show what we're doing, we'll do it that way. I actually want to write that in blue. So we have 2, raise it to the first power, and that's it. Okay, do the root first, and then the exponent. Okay, so let's look at the next one. So we have a product here, right? It's a multiplication. And since it's multiplication, we add the exponents. But then we're going to raise that to a power. So when we raise it to a power, we will multiply exponents. So let's look at it. So we have three to a power, and to get that power, we'll do our exponent arithmetic down here. Add the exponents, 1/4 plus 1/4, that equals 1/2. Okay, so that is our exponent. And what we just did was this part, right? We added the exponents, and we got 1/2, and we put that exponent of 1/2 on the 3. But now we have to do this. We raise it to the 8th power. And now we're going to multiply exponents. So exponent arithmetic, we'll do down here in red. 1/2 times 8 equals 4. So we have 4 is the exponent that we arrived at doing the exponent arithmetic. So that goes here. And now this time that is a whole number. So we don't have to put it in radical form. We just take 3 to the 4th power, 81. Okay, let's look at the next one. So this one is a negative exponent. So we know what to do with negative exponents. We just flip the base and exponent to the denominator and we make them positive. Make that exponent positive. So we have 27 to the positive 2/3, but it's in the denominator. Now that's all we do with exponent arithmetic. There's nothing further to do, so that's when we go ahead and put it in radical form. Okay, so it's still in the denominator, 27, and our exponent on the 27 is the numerator in that fraction, which is 2. The index is the denominator, which is 3. So we put the radical here, the index of 3, and now we calculate that. And again, we could take 27 to the second power. We could do that first, raise that to that power, but we would get a really big number, so we take the root first. So the third root of 27, we'll go ahead and take that quickly, and most of you know what it's going to be, but it's pretty quick to do. 27 divided by 3, 3, 3, 3. So the index is 3, so we're looking for groups of 3, and we have a group of 3. So we bring out that, and then now we do the exponent, okay? Raise it to the second power. And now we evaluate that. 3 to the second power is 9. And that's it. Okay, one more. So this time we're going to multiply exponents. And we have to remember this 1/3 applies to both things in the parentheses. So you have 8 to the 1/3. And then for the x, and you get that 1/3, I'll backtrack a little bit, because this is 8 to the first power, right? So you multiply 1 times 1/3 is 1/3. And you can also just think of that as applying that 1/3 to the 8. 8 to the 1/3. Since the exponent on the 8 is 1, multiplying, that's what you get. For x, we multiply exponents, and let's do that exponent arithmetic down below, even though you probably know what that's going to be. We have 9 times 1/3, that's 3. So that is the exponent that's applied to x, to the base x. Meant to change colors, so we get 3 as our exponent, and there it is. So x to the third, we're done with that. We're not going to do anything further with that. But 8 to the 1/3, that's the one we have to work on. And that's the one we will put into radical form. So that's 8 with an exponent of 1, since that's the numerator, and an index on the radical of 3. Okay, and we bring down the x to the third. It's not inside the radical. Move it over a little bit to make that clear. Okay, so we just have to take the third root of 8. And this time we can go ahead and take 8 to the first power. It's just 8, right? So take the third root of that, third root of 8. I think you guys know that one. I won't bother caking that one. Third root of 8 is 2. And you just bring down the x to the third. And that's it. Okay. So just to sort of recap, do all your exponent arithmetic. Then when that's all finished, if necessary, put it in radical form to simplify.